If you have understood the previous question, we shall try doing it without making any practical calculations. The enthalpy of dissociation of barium chloride solid, barium chloride or 2H2O solid, are minus 20.6 and 8.8 kilojoule per mole respectively. The enthalpy change for the reaction as given here is, what is the enthalpy change? As I mentioned, enthalpy change when bond dissociation energies are given is the summation of the bond dissociation energy of the reactants minus that of the products. Therefore, here it's been given that for barium chloride the dissociation energy is minus 20.6 minus that of the products. For products it is given as 8.8. So, minus 20.6 and minus 8.8 would definitely give me a negative value. It is minus 29.4 by adding both minus 20.6 and minus 8.8. Therefore, the correct answer is option B, minus 29.4 kilojoule per mole. Next, if enthalpies of formation of ethene gas, carbon dioxide gas and water liquid at 25 degrees centigrade and 1 atm pressure are given as follows, then the enthalpy of combustion of ethene is to solve this again. Enthalpy of combustion of ethene. Let us write the required equation. For combustion of ethene, ethene given C2H4 undergoes combustion, reaction with oxygen, I get carbon dioxide and water. Balancing this equation, carbon 2 times, I write here 2, hydrogen 4, make it 4, oxygen 2 into 2 4 plus 2 6, therefore 3 into 2 is 6. So, my required equation is ready. Now, to calculate the enthalpy change for this, I have to apply the formula. Enthalpy change delta H is equal to heat of the summation of the energy changes that are take place in products minus heat of summation of the energy changes that takes place in the reactants. That is, delta H is equal to summation of the enthalpy changes in the products minus that of the reactants. I understand that it is 2 times the enthalpy change for carbon dioxide. The second one is minus 394. I am writing minus 394 plus 2 times, and that of water, the enthalpy change for that of water is minus 286. I write it minus, I have for ethene, the first one happens to be plus 52. For oxygen it is not given. Enthalpy change for that in the standard state is regarded as 0. So, we do not need to search for it. Therefore, now as I try to solve it, I have it is minus 8, 8, 7 minus 12, 5 minus 52. Let us do this calculation. Minus 788 minus 572 and minus 52. Adding up all this, I get the value as minus 1412 kilojoule per mole. Therefore, my right option is option C, minus 1412 kilojoule per mole is the right answer. Our next question. Given that the enthalpy of combustion of carbon monoxide, what would be the enthalpy of formation of carbon monoxide? He has given the data for combustion of carbon and carbon monoxide and asking you to calculate what would be the enthalpy of formation of carbon monoxide. For this, we have to write the required equation. The required equation for the formation of carbon monoxide, writing carbon monoxide is formed from its elements carbon and oxygen, balance it, then put it as half. Now, as I look into this is my required equation. I want carbon, which is there in equation 1, if I happen to label it as equation 1 and equation 2. I retain it as it is, equation 1. I want carbon monoxide on the product side, therefore I will reverse equation 2, and I want it for 1 mole, therefore understanding that I have to divide the value of delta H naught for equation 2 by 2. Therefore, the solution for this numerical is retain equation 1 as it is, reverse equation 2 and divide it by 2. Therefore, the right option is I am retaining equation 1 as it is, I am reversing equation 2, I reverse it. You have understood this concept in the theory classes. Whenever you reverse any thermochemical equation, the value of enthalpy would remain the same with a change in sign. Since I am reversing it, therefore change in sign by plus y, and since I want it for 1 mole, it says it is for 2 mole, therefore I divide it by 2. Therefore, the right answer is, this is again equated and written as taking LCM 2, it is minus 2x plus y. Therefore, in this option C is the right option, plus y minus 2x plus 2. Our next question, which of the following is the unit of entropy? We had discussed a little while ago that entropy is defined as disorderness or randomness of a system. Entropy, again, the value of entropy will designate or tell whether the reaction is feasible, that is spontaneous or not. Entropy is mathematically written as delta S is equal to delta H by T. We are aware delta H is the energy changes, enthalpy. The unit for enthalpy is expressed in joule per mole. Temperature is expressed in Kelvin. Therefore, the unit is joule per Kelvin per mole. Therefore, the right answer is option A, joule per Kelvin per mole. The unit of entropy is joule per Kelvin per mole. Mathematically, it is written as delta S is equal to delta H by T. Our next question. If the enthalpy change for the transition of liquid water to steam is 30 kilojoule per mole at 27 degrees centigrade, the entropy change for the process would be. In the previous question, I gave you the mathematical formula to calculate entropy. Entropy delta S is equal to delta H by T. Applying the formula, we can solve this question. So let me write it. Delta S is equal to delta H by T. I understand. The enthalpy change that is being given here is 30 kilojoule per mole. Therefore, it is 30. I convert kilojoule per mole as joule per mole. Therefore, I will write it as 1000 divided by temperature expressed in Kelvin. 27 degrees centigrade expressed in Kelvin would be 300 degrees. Therefore, I understand 2 zeros taken care, 3 ones are 3 tens are. Therefore, 10 into 10, the answer is 100 joule per Kelvin per mole, as we have decided, or as I had explained to you in the previous question, that the unit of entropy is joule per Kelvin per mole. The answer is 10 into 10, 100 joule per Kelvin per mole, and the right answer is option A, 100 joule per Kelvin per mole. Since we discussed what is spontaneity, entropy, what are the conditions for predicting whether the reaction is spontaneous or not, there is a relation which binds all these three, that is enthalpy, entropy and free energy change. So your question is relevant to this. The relation between free energy, enthalpy and entropy change. This is in fact known as Gibbs equation, and the relation is, before I word it out here, it is delta G is equal to delta H minus T delta S. This equation is known as Gibbs equation. It can also be written as delta G naught is equal to delta H naught minus T delta S naught. Therefore, the right option in A, B, C and D, I arguably have it as option A, delta G is equal to delta H minus T delta S. The next question. Which of the following values of enthalpy of formation indicates that the product is least stable? There is an underlining statement for enthalpy of formation. For stability of the compounds, a general and a basic rule is greater than negative value of enthalpy of formation, more stable is the compound. I am repeating, greater the negative value of enthalpy of formation of the compound, more stable is the compound. Now let's read the question. Which of the following values of enthalpy of formation indicates that the product is least stable? I said most stable, greater the negative value, and if the question is asked on least stable, understood that it should be greater the positive value. Therefore, the right option under this, option A minus 94 kilocal, option B minus 231.6 kilocalories, option C plus 21.4, option D plus 64.8. As I mentioned, greater the positive value of delta H of formation, least stable is the compound. Therefore, the right option is option D plus 64.8 kilocalories. Connecting to my Gibbs equation, we shall solve another problem. The standard entropies of X2, Y2, XY3 are 60, 40 and 50 joule per Kelvin per mole respectively. For the reaction as given, delta H is equal to minus 30 kilojoules. To be at equilibrium, what would be the temperature? As it is connecting entropy, enthalpy, let me use my Gibbs equation as I mentioned. The Gibbs equation, as you are aware, delta G is equal to delta H minus T delta S. I am asked to calculate the temperature in this, and it is given in the data that to be at equilibrium, for a spontaneous reaction to be at equilibrium, delta G is equal to 0. Therefore, if delta G is equal to 0, I get the relation T delta S is equal to delta H. Therefore, T is equal to delta H by delta S. From the data I have, delta H is equal to minus 30 kilojoules, no doubt about it. Now I have to get what is the substitution for delta S. Now I have to get what is the substitution for delta S. You are aware delta S could be, it is calculated using the relation, delta S is calculated using the relation, that is summation of the entropies of that of the products minus that of the reactants. Therefore, if I happen to calculate the entropy value of the products XY3, it is given as 50, I take it as 50 minus summation of entropies of that of the reactants. Therefore, I have it as half of X2, my X2 value is 60, that is half of 60 plus again 3 by 2 Y2 value, that is Y2 happens to be 40 into 40. On solving this, delta S is equal to 50 minus it is 30 plus it is 20, 20 into 3 is 60, I get 60 plus 3 90, 50 minus 90, delta S is equal to minus 40. Now on substituting it here, delta H was given as minus 30 kilojoule per mole. I will convert into joule per mole as into 1000 divided by minus 40, minus minus gets cancelled, 4 ones are 25 times, 25 into 30 happens to be 75, 750. 25 into 30 is 750, therefore my right option is option C, 750 Kelvin.